explicitly to write each and every one of the 2 permutations in this set, or from this set. Okay, now how do we do this? Okay, well first we see that permutation, so let's sort of do a mathematics. So we know permutation of n comma k is equal to n factorial over n minus, and permutations are always for ordered situations. So here we want to make pairs, right, or 2 permutations. This 2 tells us the magnitude of every permutation or every permutated element, and it tells us it because every element must act as a pair. Okay, now explicitly, what am I saying here? We're saying that the 2 corresponds to the magnitude of each element that we create, and the permutation part of the question tells us that we are creating ordered, it's not spelled ordered, wait, ordered right here, okay, ordered pairs, or in other words, ordered tuples, right? But when a tuple is a size 2, so I'm telling you in technical terms and sort of, linguistic terms, we're creating pairs, but basically, mathematically, they're also called pairs, as any tuple of size 2 is a pair, right? So we want to create a pair of 2 that are unique from this set, and it wants us to show every single possible one. So how do we do that? Well, first of all, best way to do it is to list out every single individually in a row, and how many times do you list it out? It's the number of elements that you have here. So the magnitude of S here we know to be 5, which means there's 5 elements in the set S. So we'll list this A out. Then we'll list out B 5 times. B, 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 B. We'll list out C. 1, 2, 3, 4, 5. Then D. 1, 2, 3, 4, 5. Then E. 1, 2, 3. Then what I want you to do is list every single one of those letters with these pre-written letters. So it'd be A, B, C, D, A, B, C, D, E, B, C, D, E, A, A, B, C, D, once more, A, B, C, D. Now we have a bunch of pairs. Now we should do a bit of filtering. Okay, so what do I mean by filtering? There's a few of these cases that we should not. What are those cases? If you are unclear with what permutations are, you might immediately say, okay, we can rule out this, CB and also BC. Doing that is incorrect, because again, you're following sort of the set idea that the set containing A, B is the same as the set containing BA, right? That's the set idea. But again, these are pairs. So let me just make that a bit explicit. So these are all pairs, right? So the actual filtering we have to do is the following. There's no sort of natural way where we have pairs that are duplicates. Okay, pairs here aren't really. Why is it? Well, we don't consider these duplicate cases because these follow the idea of combination. Combinations ask for all basically combinations or pairings or ways of arranging an element or elements in a set. Okay, permutations ask for all possible arrangements that are unique from a given set. And when it says unique, this tells us 2 things actually. One, of course, that it's ordered, and then 2, it tells us no, we'll say tuples of duplicate value. No tuples of duplicate values. This means that we can never have a naturally occurring permutation that has these repeating sets or repeating pairs of AA, BB, CC, DD. So that's sort of the filtering we have. And then mathematically, this tells us that this should apply possibilities 5 factorial over 5 minus 2, or it would then be 5 factorial over 3 factorial, same as 5 times 4, which is equal to 20. And if you were to count this, I think you would get 20. A quick way of doing is that since these are all 5, this is 5, and this is 5, you have 5 by 5, which is 25. Then you subtracted these 5 specific cases that are not allowed. You basically have 25 minus 5. Hopefully that helps.